Hey, this is Math 6, Unit 8, Lesson 18. Alright, using data to solve some problems. We're going to work through some problems here today, just a lot of practice stuff more than anything else before we get to the homework. So the first problem is about wild bears. It says, in one study on wild bears, researchers measured the head lengths and the head widths in inches of 143 wild bears. The ages of the bears range from newborn to 15 years old, and the box plot summarizes the data from the study. So we can see the first one is talking about here the head lengths, and this one's talking about the head widths of the bears. So the ages don't matter at all, really. So we want to write 4 statistical questions that could be answered using the box plot data, 2 about the length and 2 about the width of the bears there. So again, statistical questions are going to be questions about what you see there. You could ask questions about variability, right? So which age group had the most variability, which group, male or female, had the most variability, or less variability between lengths and widths. Those are 4 questions right there. You could talk about the longest. You can ask questions about the longest. You can ask questions about the shortest. You can ask questions about the widest or the narrowest. Those are all things that you could ask. You can also ask questions about what is typical. What is a typical length of a male bear head? What is a typical width of a female bear head? Those are questions you could come up with based upon that data right there that are statistical questions. Okay? But I'll let you do those ones. All right. Activity 2. Good practice. All right, over a 2-week period, May recorded the number of math homework problems she had each school day. And here are the numbers there. It wants us to calculate the following. We're going to calculate the mean. We're going to calculate the mean absolute deviation. We're going to interpret the mean. And then later on, we're going to calculate, it stands down here, the median, quartiles, maximum, minimum, and the IQR. So we're going to put all this data together. So what I'm going to do first of all to help out is I'm going to organize this data in numerical order, least to greatest. Okay, so I'm going to have my data here, and I have a 0 and a 0, so 0, 0. I have a 1, I have a 2, so there's a 1 and a 2. I have a 5, I have a 10, I have a 12, then I have a 15, a 20, and a 25. So those are my data points there. Okay, just want to put them all in order so I can work with them here a little bit. Okay, just to organize it. It helps to organize your data. Okay, for the mean, we're going to add all this up, and we're going to divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yep. So there are 10 data points here we're working with. So when I add all this up, I end up with 90, and when I divide that by 10, my mean is going to be 9. Alright, so the mean happens to be 9. So my mean is equal to 9. Got it there. For the mean absolute deviation, okay, that's going to be the distance. Remember, that's your average distance from the mean, which was 9. So how far is 0 from 9? 9. How far is 0 from 9? 9. 1 is 8 away. 2 is 7 away. 5 is 4 away. 10 is 1 away from 9. 12 is 3 away. 15 is 6 away. 20 is 11 away, and 25 is 16 away. So to find the mean absolute deviation, I'm going to add all these up and divide by 10. When I add all these up, I end up with 74, and when I divide that by 10, I have 7.4. So my mean absolute deviation is 7.4, and my mean is 9. So how do we interpret those? When we interpret those, we can see that while on average the mean is about 9, that mean absolute deviation tells us there's a lot of variability. So we could say while on average the mean was 9 problems a day, the MAD of 7.4 shows there is a lot of variability. Okay, meaning it could be from 9, we can add that to 7 and have 16, or we can have 2, right? We're going to have a range of problems, 2 to 16, and we can see we even had 20s and 25s. So now let's calculate the following values as well: median, quartiles, maximum, minimum. So to do that, I'm going to use this data range right here to take a look at where is the median. With 10 problems, the median is going to be in the middle. So we have 1, 2, 3, 4, 5. So the median is going to be right here. Okay. So what comes between 5 and 10? Well, I have 5 plus 10, which is 15. I divide that by 2, and my median is going to be 7.5. So that's my median based upon where that point's there. For the quartiles, we're going to find the middle value, which in this case here is 3. The quartile is going to be right here, and then right here. Those are my quartiles. So that's going to be where my boxes are going to go around. So quartile, for quartile 1, it's at, the value is 1. Quartile 2 is our mean, which is our median, which is 7.5, and quartile 3 is right here at 15. Okay, our maximum value was 25. Oh, I've been writing it and can't see it, sorry. Our maximum value is 25, and our minimum value was 0. Okay, so those values come from what we have up here. So again, for making our box plot here, right, this becomes what this looks like. You're going from here to here, you have your mean there, and we're stretching to 0, and we're stretching to 25. That's the idea. Our inner quartile range is going to be quartile 3 minus quartile 1, which is 15 minus 1, which equals 14 there. Okay, so now we have the measure of variability based upon the median with this data set there. So we have variability based upon the mean. Okay, so the mean, it said, was 9, and the mean absolute deviation was 7.4. The median, we said, was 7.5, and the inner quartile range was 14. So what do we see? They both show fairly similar means. They're not too different there, and they both show a lot of variability. Inner quartile range maybe shows a little more. But they both show that there's going to be a lot of variety here, so either one would be fine to measure the center and variability. There's not one that's better than another one in this case here. So up to you what you want to say, but that's what you come up with. Let's look at activity 2. Jada wants to know whether a dot plot or histogram or box plot would summarize the center, variability, and other aspects better. So we have a dot, histogram, or box plot. So here's the values, and we're going to put them into all three forms. So first of all, let's add these values to a dot plot here. We have 0 and 0, so we'll put a dot and a dot. We have a 1 here, so put a dot there. We have a 2, put a dot there. We have a 5, which goes there. And then we have a 10, it's about there. We have a 12 there, 15 about here. And then we have 20 and 25. Okay, so there's our dot plot. Now where is the mean? The mean's a triangle. We said the mean was at 9. That was our mean. So we can put that mean value right there. There's our mean triangle. Lovely. Okay, now let's use this to take the 5-number summary from before. We had our quartile 1 was 1, quartile 3 was 15. So we're going to draw a box from 1 all the way to 15. That's our quartile range there. Okay, so from 1, so this is quartile 1, quartile 3. Now we go back and add quartile to the median, which is 7.5, so somewhere about here. And then we add our whiskers. We go, our minimum value is 0, and our maximum value is 25. So that's our box plot and a dot plot there. Now we want to take those numbers and we're going to put them into a histogram. Okay, now the histogram is going to be done 3 different ways, with a bar representing 10, 5, and 2. Okay, so here we go. So for the phone representing 10, this is 10, this is 5, this is 2. How many values are between 0 and 9? Well, we had a total of 1, 2, 3, 4, 5 values there between 0 and 9. So that's the first plot. Between 10 and 19, we had 1, 2, 3. So we had 3 right there for that value there. And 20 or more, there were 2. So we put it right there. So that's our first box plot, histogram. Okay, so we have 5, we have 3, and we have 2. Now let's do it where we break this down into widths of 5. So how many are between 0 and 4? Well, that was going to be 4. How many were between 5 and 9? Well, that was 1. 5 and 9 was 1. Yep. How many were between 10 and 14? That was actually 2. Between 15 and 19 was 1. And between 20 and 25 was 2. Oops, still too far there. That's okay. All right, so there's that box plot right there with histogram 4, 1, 2, 1, and 2. Okay, so there's that one. Now if we make it represent 2 apiece, all right, how many between 0 and 1? And between 0 and 1, we had a total of 3. Between 2 and 3, we had 1. Between 4 and 5, we had 1. And then we had to go to 10 to 11 to get one more, and then 12 to 14, one more, and then 14 to 15, one more. Then we had one 20 to 21, and we had one 24 to 25. Okay, so there's our histograms there, and you can see how when you change the bar, it changes what you're looking at. Granted, they all tend to kind of go down this direction overall, but you can see there's definitely a larger cluster over here in the smaller numbers. So of these, which of the 5 representations would you use? The dot plot, the box plot, or the histogram, to summarize your data? That's up to you when you look at. I would say overall, the dot plot gives me more, it shows all the values much more specifically. Because the dot plot shows the values, I can find the mean, I can find a median, I can find even an interquartile range or mean absolute deviation. I can find measures of variability and center with the dot plot that I can't always find in the histogram, and the box plot may not be specific enough as well. So I would use a dot plot, but it's nice visually to use the others to show what's happening with the data. All right, let's look at activity number 4. Scientists studying the yellow perch, a species of fish, believe that the length of a fish is related to its age. So the longer the fish is, the older it is. Okay? The adult yellow perch vary in size, but they're usually between 10 and 25 centimeters. So scientists at the Great Lakes Water Institute caught, measured, and released yellow perch at several locations in Lake Michigan. The following summary is based on a sample of yellow perch from one of these locations. So here's our sample. We have 0 to less than 5, 5 to less than 10, 10 to less than 15, and so on with the data. So let's use the data to make a histogram that shows the lengths of the captured yellow perch. So our first group is going to be up to 5. Okay, and then we go up to 7 for our next group, and then we go up to 14 for the next group, then we go up to 20 for the next group, and then we go 24 for the next group, and we go up to 30 for the final group. Okay, so overall we can see, here's our numbers, 5, 7, 14, 20, 24, and 30. We can see that we definitely have an increase in the lengths, and we have more up in this kind of range over here. So we have a lot of longer and potentially older fish if their theory is correct. The next question wants to know how many fish were measured. Well, to find that out, there's a couple ways. I could total this column up here, which actually equals 100, or I could add all these up here, which also equals 100. I found it easier to use a table and just count. So count the table up. Now when you look at the histogram, how would you describe the shape of the distribution? Well, definitely it is not symmetrical, right? It tends to increase and it has a peak at the 25 to 30 part there. So there's a couple things we see. It's not symmetrical and it has a peak over here. So it's increasing over the fish lengths are increasing. There's more of them as you go on. Could you estimate the median, the middle length for the sample? Okay, well, the median for the sample is going to be somewhere in the middle of the values. Knowing that I have 100 fish, I'm looking for where fish number 50 is about at, right? So this is 30 and 24, so this is greater than 50 here, which means the middle has to be somewhere in this range. Okay, so my middle is going to be between 20 and 24. Okay, between 20 and 24, so maybe a good estimate for median would be something like maybe 23, maybe 22, something like that is a good estimate for what we're talking about here. Would the mean length be greater than, less than, or equal to the median? That's a great question. So mean compared to the median. We know the median is about, again, 22 or so. What's going to happen to the median? What's going to happen to the mean length? Well, if all these values are these small values over here, and that's half of them, these small values are going to pull the mean towards this direction here. I would expect the mean to be less because there are a lot of small values that are going to make the mean decrease and become less than the median. So would I use the mean or median to describe the typical length? I would use the median because those small values are going to have a great impact on the mean. So the median is going to be a better way to describe what is typically happening and describe the center, because you want to be able to describe that center as best you can. And the center is going to be best described by the median in that case, because the mean is not going to work out. It's going to be a little bit too small. Okay? Based on your work so far, would you describe a typical age for yellow perch as a sample as young, adult, or old? Okay, well, we saw back with our data, what did we see? Moving on, With our data, what we see is that most of the perch are in that 20 to 30 range. So over half of them are in this range, which means over half the fish are long and also old. Think of this as being young, think of this as being adult, and this as being old. If you kind of want to cluster each one. There are definitely a lot more older fish than there are younger or adult fish. So I'd go with the old ones there. That makes the most sense. So some researchers are concerned about the survival of the yellow perch. Do you think the lengths or the ages of the fish in the sample are something to worry about? Well, that's a great question. We probably would say yes, because there are more old fish than young fish in the sample. So the question can be, where are all the young fish? Why aren't there a lot of young fish in these samples here? Why are there so many more old fish? That would be something that a researcher might be concerned about, because overall you want to make sure that those populations are increasing, and this shows that the young fish are not increasing at the same rate as the old fish. So why is that? That's another question for them to figure out. Okay, we're going to pause there, let you work on your homework. We'll come back and check it together in just a few minutes. All right, homework for Math 6, Unit 8, Lesson 18. It says 20 students timed how long it took them to solve a puzzle. Here's a dot plot of their solution times. Predict which measure of center, the mean or the median, will be larger, and explain your reasoning. Okay, so overall, this shape here is symmetrical, but because we have this one over here, this little bloop right there, it's going to have an impact on which value? The mean, wouldn't it? Okay, the median number is probably going to be pretty simple to say. The median is going to stay the same pretty much no matter what. That's probably a good estimate for median there. But because of this number here, the 2, that's going to push the mean value to be a little bit less. So I would expect the median to be greater than the mean because of that number 2 value right there, which messes the whole mean up. So when we calculate the mean, what do we get? Well, the mean for this data set here is going to be, when we add all these numbers up for the mean, we have 174. When you add 2 and 6 and 7 and 7, we have that many, and we're going to divide it by the number of students, which is 20. So 174 divided by 20 is 7.7. For the median, we find the middle value, which is between 10 and 11. So we can count either way, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the median's right here between those, which is all in the same place, which is the value of 9. So the median is equal to 9. So, was my prediction correct? Yes, right? The median is bigger than the mean. Granted, I wrote it backwards this way, but it's the same thing. Median's greater than mean. So which pair of measures of center of variability, mean and MAD, or median and IQR, would you choose to describe the situation? Well, again, when I have this number out there, when I have a number that shifts the mean and throws it off a little bit, it's better to use the median because there is less variability when you use the median, okay? Or we want to use the median, okay, so because there's variability, we should use the median. When there's lots of variability, the mean is not a good data set for us because it's going to change what things look like. So this is going to be a more accurate measurement for us to use. Number 2. A local library showed a movie during a children's festival. Jada recorded the ages of 100 children who watched the movie. So here's a histogram of 100 children. So we have 100 kids. Way to go. Can the histogram be used to estimate the mean age of the movie? Well, the mean is going to be the value in the middle. To do that, we want to decide, is it symmetrical? Yeah, we would say yes, and that's because it's symmetrical. So you could probably estimate that the mean is going to be somewhere in about the middle, right? So the mean's probably somewhere in here between 5 and 6 is probably a good estimate. Because it's symmetrical, it's going to work okay. Can the histogram be used to estimate the median, the middle? Yeah, same reason here. We can tell that based upon the numbers with 100 people, you're looking for number 50 or so. And we can tell that we have, from here, we have 10 and 25, that's 35. So between 35, the number's 35, and then over here, this goes to 50, 85, which 50 is going to be in between 35 and 85. It's going to be in this bar right there. So yes, and we could say it's going to be about between 5 and 6. Oh, between 5 and 6. Now, can we find the exact median age? Nope, we can't find the exact median age. And the reason for that is we just know it's between 5 and 6. It could be all 5s, it could be all 6s. So it's hard to tell from the histogram. We can't do it exactly. Is it possible to tell from the histogram if there was at least one 3-year-old? Well, 3-year-olds are going to be in this range right here. But this range goes from 3 to less than 5. So in that box right here are 3-year-olds and 4-year-olds. They're both in that box. But they could all be 4-year-olds. We don't know. You can't tell from that. So we would say no to that one as well. And then finally, I think a couple more. In the game, players are shown pictures of 14 butterfly shapes hidden in it. They are given 3 minutes to find as many hidden butterfly shapes as they can. There's 24 4th grades, 24 6th graders, and this is how many shapes they found. So what do we notice about this dot plot? So write a few sentences about what you see happening, the differences between the two groups. Overall, we could say that the 6th graders seem to find more butterflies than the 4th graders. They were able to find more. We could say that they had the most with 14 compared to the least over here at 0, that there are some kids who found nothing. So these are some things you might notice or be able to talk about when it comes to that dot plot right there. So write a couple sentences that explain that. Okay? And then finally, our very last one for the day and also for the year for me, it says in a round of mini golf, Helena records the number of strokes it takes to hit a ball in a hole. Find the range, median, and interquartile range, the IQR. All right, so these are not in order, so the first thing I want to do is put them in order. So let's do 1. We have 2 2s, so 2, 2. We have 1, 2, 3 3s, 1, 2, 3 3s, 2 4s, 4 and 4, and a 5. Okay, so the range, what's the range going to be? That's going to be the biggest, the maximum, subtracted from the minimum. 5 minus 1 is 4. Okay, so there's our range. The median is going to be the number in the middle. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So the median is going to be 1, 2, 3, 4, 1, 2, 3, 4. This is our median right there. So our median is equal to 3. And to find our interquartile range, I need to find what quartile 1 is and quartile 3 is. So quartile 1 is going to be in between these values, and quartile 3 is in between these values. Well, fortunately, the values here is 2 and 2, which means quartile 1 is going to be equal to 2. Quartile 3 is between 4 and 4, so it's 4. So interquartile range is 4 minus 2, which equals 2. So we have our IQR, our median, and our range right there for you. That is it for today and it for the year. Thank you so much for watching. Hope to see you next year in Math 7 and then again in Math 8 because they're all ready for you next year and the year after that as well. Have a great day and a great year. Bye-bye.